Yes, students. In the previous lectures, we had discussed very important steps of the metallurgy, and that was associated with the concentration of the ore and the extraction of the ore. We understood the purpose, that why we were doing concentration and extraction. So concentration was done to remove earthy impurities, and for the removal of earthy impurities we have applied various methods. But somewhere we fail to remove all type of the impurities, since there are certain type of the impurities which are volatile and which cannot be removed in the concentration steps by applying various methods. So we did extraction. Extraction was consisting of important part, that was conversion of metal compounds to metal oxides and reduction of metal oxide to metal by using different methods. So this is the step of the metallurgy where we got the metal, but still again we are failing to remove all type of the impurities even in this step also. So the metal that we are obtained is consisting of the impurities. So the question is that if the impurities are removed in the concentration as well as in the extraction, then from where these impurities comes? So these impurities comes when we are doing the process of what, extraction. Within the process, these impurities get embedded with the metal. So it is very important to remove these impurities of the metal. Now the metal which is obtained from the extraction is consisting of some kind of impurities, and this impure metal is referred as crude metal. Since this crude metal is consisting of impurity, so in order to get pure metal, we have to remove all the impurities which we obtain within the processing. So the next step of the metallurgy is involving removal of impurities from the metal, which we will refer as what, refining. After doing refining, if you will see, we can get the pure metal. So in this session, we are going to learn in detail about refining of the metal. So in science, if you will see, when we discuss about refining, so refining can be defined as, it is consisting of purification. It's a very important word here. It's a purification of crude metal. Now, what do you mean by crude metal? This is the metal which is obtained by the steps called extraction and which is consisting of unwanted particles. Since this metal is not 100% pure, it is consisting of some amount of impurities which get associated during the process of extraction. So this metal does not have complete property of that original metal. So we cannot use this metal, or this metal cannot withstand 100% with our requirement. So this metal is referred as crude metal, which is consisting of impurities. So we are purifying this crude metal by removing metallic and non-metallic impurities. So basically in the refining step, we will remove the impurities which is associated with the crude metal. Since we know that all the metals are different, so the metals which are subjected for the extraction will have the different properties, and the type of the impurities will also be different. So we cannot apply same method for refining to all the metals. For different metals, we have to apply about different methods. Different principles of the science are used. So if you make the list of refining, then you'll find there are various methods which are generally used for the refining. Like first is distillation. We have heard this word in the previous classes also. So distillation can be a method for refining of the metal. Some metals are refined by distillation. Some method requires liquation. Like distillation is one method of refining, liquation is also one method of refining. There is another method which involves the principle of electrolysis, which we referred as electrolytic refining, and polling, which is another method of refining, zone refining. If you will see, vapor phase refining, and finally is what, chromatography. So these all methods are collectively called as methods of refining. So the methods that we are using for refining can be of 7 types, and it can be distillation, it can be liquation, electrolytic refining, poling, zone refining, vapor phase refining, and chromatography. So let us discuss these all methods one by one. Well, so let us understand various methods of refining one by one. The very first that we are going to discuss is distillation. In distillation, if you will see, always we convert one substance into its vapor form, and again that vapor is allowed to condense to get back the original component. The same phenomenon is used also in the refining of the metal. Basically, if you will see, we are using this method to remove non-volatile impurities from volatile metals. Now we know that the crude metal is consisting of pure metal as well as some impurities which is associated with it. So here if you will see, when I am talking about removal of non-volatile impurities from volatile metals, so generally we refer non-volatile word to that component which will have very high boiling point, student, because boiling point and the volatility are what, inversely proportional. So when you say any substance as non-volatile, it is very difficult to make its vapor, means its boiling point is very high. So in this case, the impurities which are associated with the metal will have very high boiling point and they are very difficult to convert into the vapor form. And the metals which are associated with these impurities are volatile. It means what? The metal will have low melting and boiling point. So basically this method can be used for those metals which are volatile. It means that the metal which will have low melting and boiling point. So in this mixture of metal and impurities, if you compare the difference of the melting point, so the impurities will have high boiling point and the metal will have low boiling point. That's why impurities are referred as non-volatile and metal is referred as what? Volatile. Now let us take the example of some volatile metals or the metals which will have low melting and boiling point. Say for example zinc, cadmium and the mercury. So generally in the metallurgical industry, if these metals we want to extract which will have low melting point or which can be easily vaporized or which can be consisting of non-volatile impurities, can be easily purified by the process of what? Distillation. This is the common principle that we use for the refining of the metal. What we do in this, we take this crude metal pieces into a retort. When you say retort, so you can simply refer as it is a distillation flask like structure. We take impure metal. If you will see, we are taking impure metal at the bottom. This is the pieces of the impure metal which is consisting of what? Volatile and non-volatile components. So if you will start heating it, so the substance or you can say metal which will have low melting point will vaporize first. Let's say these are the vapors of the metal. Now these vapors are taken out into the condenser and they again converted into what? Liquid form. After converting into the liquid form, they are solidifies and we get the pure metal. But all the impurities remain at the bottom of the flask. Now these impurities remains at the bottom of the flask because they are non-volatile and they have very high boiling point. So in retort, if you will see, onto the upper part you will find the vapor of the metal and at the lower part you will find what? Impurities. So pure metal, we can say it vaporizes and this vapor of the pure metal is taken into another apparatus which is called as condenser, where we are condensing the metal vapors and forming what? Liquid. And at room temperature that liquid of the metal solidifies to give pure metal and non-volatile impurities that remains at the bottom of the retort. Next method of refining, that we refer it as liquation. Student, as the name suggests, when you say liquation, so which state of the matter comes in our mind? Yes, it is liquid. So when we talk about liquation, basically we convert impure metal, or you can say crude metal, into the liquid form. So it is very important to understand which type of the metal can be easily converted to the liquid form. Suppose if we have option, the metal which will have low melting point and the metal which will have high melting point. So which type of the metal can be converted easily into the liquid form? Yes, the answer is the metal which will have low melting point. So basically, if you will see, the liquation is applied for refining for those metals which have low melting point or which can be easily converted to liquid form. So for that purpose, the impurities which are present into that metal should have higher boiling point or melting point than metals. So basically, we are applying this method for removal of impurities which have higher melting point. See, it's very important. This method is employed when impurities have higher melting point than required metal which is to be refined. So if you'll compare the melting point of these two, then you'll find impurities which are associated with the metal will have higher melting point and the required metal should have lower melting point. You got this? See, the principle which is based on this method is we are heating this crude metal. So the low melting metal forms fusible liquid. Now what do you mean by fusible liquid? It is the molten state. When you say fused state means what? Molten state. So lower melting point metal forms fusible liquid easily on heating and it flows down. If you'll see here, the metals which are refined by this method is what? It is bismuth, tin, lead and mercury. Basically, if you will see, the metals like bismuth, tin and lead, these all belong to p block metals, and p block metals have low melting point comparatively d block metals. In case of d block elements, if you will see, the mercury which is liquid at room temperature have very low melting point. So it is very important for us to remember the name of these metals since it comes in the MCQs. Which metals are refined by liquation? So it can be bismuth, it can be tin, it can be lead and mercury. Now let us understand the working of this, what we do. If you'll see, on the top of this furnace, here we are adding powdered form of the impure metal or crude form of the impure metal. When this impure metal gets collected onto this part, then slowly it falls onto the surface of this base. This base is called as what? Sloping hearth. This sloping hearth is heated enough to melt the metals but not to melt the impurities. So it is very important to control the temperature. Please remember, the metal have lower melting point and the impurities which are associated have higher melting point. So we are heating only to melt the metal, not to melt the impurities. So onto the base, when these metal particles spend some time, so they absorb heat and they gets converted into the liquid form. Since the liquid has a property of the fluidity, so this liquid flows and it gets collected to another container. Now this liquid which flows, it leaves behind these impurities which got stuck onto the surface of what? This sloping hearth. So the liquid which is obtained here is free from the impurities. Now this is pure metal. Let's learn new method of refining, and this method is referred as electrolytic refining. As the name suggests, student, the word which comes into this method is what? Electrolytic, means there is something to do with the electrolysis? Yes. In this case, we are refining the metal by using the process of electrolysis. So generally when we carry out electrolysis, then always there are certain kind of setup is required. For example, the required material, say for example it is the non-conducting vessel, and this non-conducting vessel is referred as electrolytic cell or electrolytic bath. It must contain molten or aqueous solution of what electrolyte, which contains what free ions. And into this, if you'll see, we have taken two metallic or non-metallic plate, which is conductor of electricity and connected to the opposite terminal of the battery, and they differ in their functions. So the one which is connected to positive terminal of the battery is referred as anode, and anode is responsible for the process of oxidation. Now the one which is connected to negative terminal of the battery is referred as cathode, and the reaction which takes place at cathode is what? Reduction. Generally the deposition of the metal takes place at cathode. So when we do refining of the metal, then anode and cathode is made up of same metal, but the difference is what? The purity of their metal. For example, the impure metal is made as anode. This crude metal, you can say, the metal which is to be refined, is used to make anode. So crude metal is kept at anode, and same pure metal, a thin strip of the pure metal, is kept at what? Cathode. Suppose if I have to refine copper metal, so anode will be made up of impure copper, and the cathode will be made up of pure copper. So the electrodes are made up of same metal, only there is a difference of what? Purity. So we always take crude metal at anode and pure same metal as what? Cathode. And this electrolytic solution must contain metal ion of the same metal which is to be refined. So suppose if I have taken copper metal under refining process, so this electrolyte must contain copper 2 plus ions, okay, or any metal ion, student, the metal which is to be refined. So when the process starts, what happens? The metal ion, or you can say the copper 2 plus ions which are present over here, being positive charge, it gets pulled toward negatively charged electrode, which is called as what? Cathode. Cathode starts attracting these metal ion onto its surface, and there is a process reduction take place. Now we know that reduction is a gain of electron. So if we talk about copper 2 plus ion, to discharge copper 2 plus ion, it gains 2 electron and it forms copper metal solid. So this copper metal solid slowly get reduced and deposit onto the surface of what? Cathode. Due to the deposition of the copper 2 plus ions onto the surface of cathode, the concentration of these metal ion into the solution decreases. So to maintain the concentration, since the anode is made up of same metal, that metal starts oxidizing and producing its own ions. Means this anode, which is made up of copper, it is producing copper 2 plus ion. So every time as the anode undergoes oxidation and it produces copper 2 plus ion, and every time this copper 2 plus ion which comes from anode get deposited onto the cathode, this process takes place simultaneously. So what happens? Every time the concentration of the copper 2 plus ion from the solution decreases, which is maintained by oxidation of this anode. So if this process continues, what happens? Because of the oxidation and production of copper 2 plus ion, the mass of the copper anode decreases, and because of the deposition of the copper metal, the mass of the cathode increases. Please remember, only the metal ions are migrating and depositing onto this. So from anode to cathode, if you'll see, there is a transfer of only metal ions, not the impurities. So impurities remains collected at the surface or at the bottom of the anode, which we referred as anode mud. It is used to refine metals like copper and the zinc. And if you will see the impurities which are collected at the base of the anode, which is referred as anode mud, can be consisting of Sb, Se, Te, Ag, Au and Pt. Basically, in case of electro refining of the copper, sometimes this anode mud which is obtained is not thrown because it is consisting of certain valuable metal, and these valuable metal may be what, silver and gold, so which can be refined again by a process of cupellation. So mostly we can say these less electropositive impurities go on collecting near the anode, and this we refer as what, anode mud. So by doing this method we can obtain about 99.99% of the pure metal. Method of refining is polling. So basically student, when we use polling, so it is applied for refining of those metal which is consisting of oxide as an impurities. For example, purification of copper or tin is basically done by what, polling. So in case of polling, we are refining copper and tin, and which contains oxide as an what, impurities. So what we do in this, first we take one container, and into this container we are taking what, molten pieces of what, metal. This is the molten impure metal which is consisting of what, oxide as an impurities. So this molten metal is stirred with the green log of wood. Here the green log of wood is acting as what, stirrer. So when you will stir with this green log of wood, which is a type of hydrocarbon, so it is consisting of carbon and hydrogen. So the part which is part of this green log of the wood which is dipped into what, this molten metal, it start releasing its volatile oxides. If it is made up of hydrocarbon, so it is going to release CO2 and H2O. So these volatile oxide of the green log of the wood immediately combine with this oxygen, and it forms volatile gases and removes from the impure metal. So if you will see, the principle which is used behind this is this. See, the hydrocarbon gases liberated from the green wood reduces the metal oxide into the metal. It's very important. This hydrocarbon material which are forming volatile gases, and the volatile gases helps in reducing metal oxide into the metal, and this is how we are able to reduce this impure metal to pure metal. At the end of the process, if you'll see, all the molten metal is collected near the bottom of the container, and all the impurities get collected onto the surface, that we referred as what, scum. You can see, so scum is consisting of impurities, and this molten metal is the free metal into the pure form. Let's proceed to new method, next method of refining, and this method is referred as what, zone refining. So this is one of the most modern method you can say, and by doing zone refining we can achieve 99.999% of the pure metal, or you can say the highest purity of the metal can be achieved by this method. What we do in this method, suppose if this is the cylindrical rod of the metal, and this is consisting of certain kind of impurities. Now if you see, this blue particle which I have shown is consisting of what, impurities. So what we do, we heat one end of the metal. This is the coil, electrical coil, and by using this we are heating one end of the metal. The principle which is based behind this is, if you will see, when an impure molten metal is melted and allowed to solidify, then impurities move away from the solid region and prefer to distribute into the molten region. What they want to say, student, Suppose if this is the impure metal and which is consisting of some kind of the impurities, so if you will heat one side or one end of the metal electrically, then this impurities have more tendency to dissolve into the molten state. Every time if you will heat any one region of this metal, then the impurity transferred from the colder region to what hotter region. Suppose if this coil, by using this coil, if I am heating one end of the metal, and the moment if this coil is shifted from one end to another end, so the side where we are bringing this coil, that region will become more hot, or you can say it is just about to melt the metal. So the impurities which are present onto the colder part will transfer from colder part to hotter part of the metal. It is because the impurities which are present into the metal have more solubility to the molten part of the metal. So every time if we shift the coil from one end to another end, so we will able to collect all impurities at one part of the metal. When enough impurities of the metal will get collected at one end of the metal, then we discard it by cutting that piece of the metal. So this is how we achieve what? Refined metal by this method. So next method of refining or purification of the metal that we are going to study is referred as vapor phase refining. Generally, if you see in case of vapor phase refining, student, the metal is allowed to convert into volatile compounds. When I am saying it is volatile compound, so it is very easy to thermally decompose the volatile compound of the metal and to get back original pure metal. So the very first step, we convert metal into its volatile compound by using certain suitable reagent, and that volatile compound is again on heating or thermally decomposed to give what? Pure metal. This method of vapor phase refining can be used for certain specific metals like nickel, zirconium and titanium. So it is very important for us to remember the name of metals, because in multiple choice questions and also other type of the questions, they ask which type of the metals are refined by vapor phase refining. So these metals are nickel, it can be zirconium and it can be what? Titanium. In vapor phase refining, actually we are removing oxygen and nitrogen type of the impurities from the metals. Vapor phase refining is used in case of nickel, and this process is referred as Mond's process, and in case of zirconium and titanium, this process is referred as what? Van Arkel method. So please remember, this Mond's process is a type of vapor phase refining for refining of the metal, and Van Arkel method is again, it's a type of vapor phase refining for zirconium and titanium. So let us understand one by one. Mond's process, which is vapor phase refining for nickel. So what we do, we refine metal over here, that is nickel. Let's say this nickel, which is consisting of what? Impurities. So this impure nickel is treated with what? Carbon monoxide gas. Now this carbon monoxide gas is very strong ligand. It has more ability to form metal carbonyls, which is a volatile complex. So if you will see, since this nickel is consisting of nickel metal as well as what? Impurities, but this carbonyl does not react with the impurities, it reacts only with the metal. So here the metal, that is nickel, only nickel combines with the carbonyl and it forms suitable compound at 350 Kelvin, and this compound is called as tetracarbonyl nickel. This is the volatile unstable complex form. Now this, after formation of the volatile complex, this complex is again heated above temperature than the previous one. So at higher temperature, what happens? This part breaks and this carbonyl part, which is a gaseous product, is given out. It leaves behind this residue. So this residue, if you will see, it is what? Free from the impurities. So it is the highly pure nickel. So what we have done in this step, if you'll see again, the metal and the impurities is allowed to react with the carbonyl. Carbonyl react only with the metal, it does not react with the impurities. It first forms volatile unstable complex, that is tetracarbonyl nickel, and that complex is again thermally decomposed at higher temperature to give residue, which is highly pure. This is nickel metal. Same vapor phase refining is done in case of refining of zirconium and titanium by a method that is referred as Van Arkel method. So in this case, we are converting zirconium and titanium into volatile complex of their respective iodide. So this is, if you will see, this is zirconium, and which is consisting of what? Impurity. So when it is treated with the iodine at about this 870 Kelvin, so this iodine does not react with the impurities, it reacts only with the zirconium. So the zirconium from these impurities comes out and it reacts with iodine and it forms volatile unstable complex of zirconium tetraiodide. Since this zirconium tetraiodide is a volatile unstable complex and it is heated at very high temperature to get rid of this iodide part. So this zirconium tetraiodide at this higher temperature decompose to give a sublimable product iodine, which is a gaseous product given out, and it leaves behind residue of what? Zirconium. All the impurities, oxides and nitrogen also removes by this method. Same thing we are doing with the titanium. Like zirconium, the impure titanium is again treated with the iodine and it forms titanium tetraiodide volatile unstable complex. After formation of this volatile complex, again we are heating at very high temperature, so this get decomposed and this volatile part, that is iodine gets evolved and it leaves behind the residue of what? Titanium. So here we are getting pure metal residue as what? Zirconium and titanium, which is free from what? Impurities. So this is how Van Arkel method is carried out for zirconium and titanium for the refining of this method, which comes under vapor phase refining. Let's move to the next method, and very popular method which is used for the refining of the metal is what? Chromatography. Now there are various types of chromatography like column chromatography, paper chromatography, thin layer chromatography, but here we are specifically discussing about what? Column chromatography. So in any case of student, when we say chromatography, so we all know that chromatography is a modern technique which discuss about purification of the components on the basis of their different rates of adsorption. So basic principle which is based behind this, if you'll see, is what? Selective adsorption. When you say selective adsorption, the different components have different rate of adsorption. Only on the basis of the different rate of adsorption they can get separated into that column. So we can say this method is based upon the selective adsorption of components of a mixture. In this case, if you see, the different components of mixture are adsorbed to different extent to an adsorbent. Now, if it is applied for the refining of the metal, basically in case of column chromatography, there is a column and it is filled with a material which is acting as what? Adsorbent. When I'm saying adsorbent, so the function of this substance to adsorb another substance onto its surface. And any kind of chromatography, if you'll see, it is consisting of two phases. One is what? Mobile phase, which is acting as adsorbate, and one is what? Stationary phase, which is acting as adsorbent. So this column, student, if you'll see, it is filled with the stationary phase, which is adsorbent, and from here we are taking what? Adsorbate, that is the mobile phase. Generally in case of refining of metal, we pour molten metal. If this molten metal is poured slowly into this column, since this molten metal is consisting of what? Mixture, some particles of what? Impurities and more particles of what? Metal compounds. So the impurities and the metal compounds will have different rate of adsorption onto this column. So as we allow this molten metal to pass through this column, so depending upon their rate of adsorption, you will find different layers. If you see, the position of these layers onto this column is different, that clearly indicate their rate of adsorption onto the column and rate of solubility into the liquid which is poured is what different. If you see this color which is at the lower position, that indicates it has less adsorption. So this can be easily removed from the column, and this red color band or the band which is above or upper position of the column, that indicates it has more rate of adsorption, so it want to spend more time into the column, so their removal will be what different, or it can be removed with difficulty. So we are getting two different bands or two different layers. It is because of different rate of adsorption. Always remember, the layer which is at the lower position will have less rate of adsorption, and the layer which will have upper position onto the column will have higher rate of adsorption. So if this solution is continuously poured, then this layer will come out slowly from this column, and it can be taken into what separate container. Say for example, the component which is adsorbed to less extent onto the adsorbent will spend less time into the column and can be taken out easily. So in the first fraction you will able to select that component which have less rate of adsorption. Once if you have selected or removed this fraction of the component, then another fraction of the component which will have less adsorption or which can be removed with difficulty can be removed into what another container. So by doing this, suppose if we are taking impure molten metal which is consisting of what impurities and the metal compounds, so they can be separated and purified into the different fractions because of the different rate of adsorption. You got this? This is how we can remove metal as well as what impurities, since they have different rate of adsorption. So in one fraction we can separate impurities, and in another fraction we can separate what? Pure metal. So far we have understood about the metallurgy, that the metallurgy involves various scientific techniques and it helps us to extract pure metal from its ore. So when we talk about various metallurgical processes, student, then these all are scientific processes which is based upon various scientific principles and helps us to extract pure metal from its ore. So if we just sum up all these processes, then the very first thing that the metallurgy starts is what? Ore. Now, ore are the naturally obtained mineral from where metals can be extracted profitably. So the very first thing, once we get ore from the nature, we just convert into what? Small pieces, which we say as pulverized ore, or we can also make it into what? Powdered form. Since this ore is consisting of earthy impurities which we had referred as gangue along with metal compounds. So we have to remove these earthy impurities, which is done in the very first step that we had referred as what? Concentration. So concentration is the first step of the metallurgy. As we had discussed, since the ore is consisting of various types of the gangue particle, so they cannot be removed by using one single method. So depending upon the impurities and the metal compounds, we apply different methods in concentration. So basically, the concentration methods that we apply is for hydraulic washing. Now this hydraulic washing is applied for all type of ore. Magnetic separation is applied only if any one component in the ore is what? Magnetic in nature. It can be gangue particle or it can be metal compounds. We apply froth flotation for metal sulfides and leaching for certain metals like aluminium, gold and silver. So concentration is the step which involved in the metallurgy, which helps us to remove what? Gangue particle. Student, maximum amount of the gangue particle we removed by using all these methods, but still there are certain gangue particles which are volatile in nature and which can be removed only by heating. So we have to do another step which we referred as what? Extraction. So extraction can be the second step of the metallurgy. In extraction, there are two major things that we do. The very first, we convert metal compound to its oxide. Now, the reason of converting metal compound to its oxide so that we can easily remove metal from its oxide. Once metal oxide is formed, immediately we do reduction of the metal oxide. Now, metal oxide is converted to free metal. Now, if you will see, conversion of metal compound to metal oxide can be done by two processes and it totally depends upon the type of the ore. We can use calcination and roasting. So calcination is applied for carbonate type of the ore and roasting is applied for the sulfide type of the ore. In both the processes, we are heating the ore below the melting point of the metal. Once metal oxide is obtained, next step in the extraction is metal oxide is converted to free metal and there are various thermodynamic principles involved in this process. So this process is called as reduction and it can be done in different ways like hydrometallurgy by using aqueous solution of the substance or by strong heating, that is referred as pyrometallurgy, and also by using the principle of electrolysis, which we referred as what? Electrometallurgy. Once we got the metal in the extraction step, that metal is not 100% pure. It again consisting of what? Impurities. So this metal is referred as crude metal. So it is very important for us to remove these impurities into the next step, and which we refer as what? Refining. So refining is the third major step. In refining, we are removing impurities of the crude metal, and depending upon the metal and its physical properties, there are various types of refining used. Say for example, distillation. We can also use liquation, electrolytic refining, pulling, zone refining, vapor phase refining, and chromatography. After doing this refining, we are getting what? Pure metal. So whenever we are talking about metallurgy of any metal or extraction of any metal, so that metal has to undergo all these various steps, and depending upon the suitability of all these steps, we select most suitable step for concentration, extraction, and the refining. So in further steps, we are going to learn about extraction of zinc, aluminium, iron, and copper metal. Now let us understand the extraction of very important metal, that is zinc. Now we all know about the zinc, which is very important metal, and if you'll see some important uses of the zinc metal, it is used in case of galvanizing iron. Now the galvanization of iron means what? Since iron metal is very reactive and it undergoes corrosion, so it forms unwanted material onto its surface, which we refer as what? Rust, and commonly it is referred as rusting of iron. So to prevent rusting of iron, the surface of the iron metal is coated with zinc. So this coating of zinc onto the surface of iron is referred as galvanization. So the metal which is used for galvanization is zinc. So this is one of the important use of zinc, which prevents iron from its corrosion. It is also used as a reducing agent. Since zinc metal have very low SRP value and it can act as strong reducing agent. So in so many processes you will find the zinc metal used as reducing agent. It is also used to make alloys like brass, German silver, and there are so many other alloys. So it is very important for us to extract zinc. Now if we talk about the minerals and ores of the zinc, if we make the list, the very first is what? Zinc blende. Zinc blende can be represented as ZnS, which is chemically referred as zinc sulfide because there is association of sulfur with zinc. Zincite is the another mineral, and if you will see, it is zinc oxide. Calamine, which is the ore of the zinc, which is referred as what? Zinc carbonate. And willemite is zinc silicate. It can be zinc silicate. Out of these ore, if you will see, the mineral which is used for the extraction, which gives most profitable extraction, is what? Zinc blende. So that is the reason why zinc blende or zinc sulfide is referred as chief ore of the zinc. So once this ore is taken from the earth crust, then it is followed by the various metallurgical processes. So in the extraction of zinc from the zinc blende, when we talk about the very first step, the first step for the extraction is what? Common, and we know that this is concentration, and in this concentration step we remove gangue particle, that is earthy impurities from the metal compounds. So the method that we are using here is what? Gravity separation. Since gravity separation is applied for all type of the ore, and by doing this we are able to remove lighter gangue particles. We also apply electromagnetic separation if iron oxide is present as impurities. Along with the zinc blende, if the iron oxide, which is the magnetic ore, then we apply what? Electromagnetic separation. But here the ore is present in the form of sulfur, and metal sulfide does not get wet by water. So the best method that we are using is what? Zinc blende is a sulfide ore. So sulfide ore, the method that we use. In order to extract any metal from its ore, we all have to apply these all processes. Now selection of the process totally depends upon the metal compounds. So if we discuss metallurgy of what? Zinc, so let us understand why zinc metal is important for us. So let's see some uses of zinc metal. If you'll see, zinc metal is used in case of galvanizing iron. Student, you must have heard the process galvanization, which involve coating of zinc metal onto the surface of iron. But why we do this? Because iron, being more reactive metal, if it is exposed to the atmosphere, it forms undesirable compound onto its surface, that is reddish brown color, ferric oxide, which we refer as what? Rust. During this process, what happens? The iron undergoes what? Its loss. So to prevent this loss, we coat this iron metal with zinc metal. So coating of zinc metal onto the iron is referred as galvanization, and this is one of the important use of zinc in preventing corrosion of iron from its component. It is also used as what? Reducing agent. Now the reason the zinc being reactive metal, it is having very negative value of SRP, and because of this the zinc is acting as what? Reducing agent. So various processes, zinc metal powder is used as reducing agent. It is also used to prepare alloys like brass, German silver, and everything. So because of these uses, zinc metal is very important for us. So extraction of zinc, if you'll see, minerals and ores, if you'll see, zinc blende, and the formula of the zinc blende is ZnS. We need to learn these formulas because sometimes in the exam they ask zinc sulfide, chemically we can say. Something more, zincite, which is referred as zinc oxide, calamine, which is referred as zinc carbonate, willemite, which is referred as zinc silicate. So zinc sulfide, zinc oxide, zinc carbonate, and zinc silicate. Out of all these minerals, student, most profitable extraction of zinc is carried out by zinc blende. Hence, zinc blende is referred as chief ore of zinc metal. As we all know that once we get the ore powder form, then the very first step we carry out in the metallurgy is what? Concentration. So in concentration, the naturally obtained ore, which is consisting of gangue particle or referred as impurities, can be removed. So namely, the methods that we are using over here is what? Gravity separation. So this gravity separation is applied for all type of ore. It removes lighter gangue particle, since the principle which is based on this is removal of lighter gangue particle and the denser metal compound. If zinc blend is consisting of magnetic ore as iron oxide, then we also applied this method of electromagnetic separation. And since zinc blend, the formula of the zinc blend is ZnS, and there is association of sulfur with the metal, it makes this compound hydrophobic. It does not get wet by water. So we just add this method, Prof flotation. The Prof flotation is the more correct method to apply for zinc blend ore. After applying concentration, the next method of the metallurgy that we know as what? Extraction. So in extraction we do two things, student. The very first thing, we convert metal compound to its oxide, and second thing, metal oxide is converted to metal, that is referred as what? Reduction. So let us understand how we convert metal compound to metal oxide. So this can be done by a process of calcination or roasting. But if you will see zinc blend, since it is sulfide ore, so the process of conversion of ore to oxide is applied as what? Roasting. So what is roasting that we have learned just now? Roasting is what? It is the conversion of metal sulfide to metal oxide by heating that ore into excess of air. So if you'll see this, roasting, as we know that this is carried out in the reverberatory furnace, and the temperature of that furnace is maintained around 1200 Kelvin. So when zinc sulfide is heated with the excess of air at about 1200 Kelvin, so here this oxygen which has come from air is acting as oxidizing agent. So it starts reacting with the zinc metal as well as sulfur, and it oxidizes zinc and sulfur to its respective oxides. Zinc forms zinc oxide, which is a solid substance, and it remains in the residual form, and there is sulfur dioxide gas evolved in this process. So if you'll see this zinc sulfide, we have converted towards zinc oxide by heating in the excess of air. So this process is referred as what? Roasting. Sometimes if enough quantity of the air is not passed, so there is chances of formation of zinc sulfate. Please remember, student, extraction of metal from its oxide is very easy. If zinc sulfide gets converted to zinc sulfate, then it is very difficult to extract zinc. So what we do is that we do thermal decomposition of the zinc sulfate. If zinc sulfate has formed along with the zinc oxide in the roasting process, then it is heated at this higher temperature, and it converts or decomposes zinc sulfate into zinc oxide back, and there is an evolution of sulfur dioxide and the oxygen gas. So we always prefer excess of air while doing what? Roasting. So this is how we are converting zinc blend to what? Zinc oxide by a process of what? Roasting. The moment we have converted zinc sulfide to zinc oxide, now the next step is what? Extraction. That is conversion of metal oxide. Here the metal oxide which we obtained in the previous step is what? Zinc oxide, into free metal. So if I want to convert zinc oxide into zinc, this process is referred as what? Reduction. For reduction of zinc oxide, the process we are using is what? Pyrometallurgy. Now pyrometallurgy always involve what? Heating of metal oxide at very high temperature, but only by heating zinc oxide, zinc cannot be extracted. So we have to add certain suitable reducing agent, and we can heat at higher temperature. Here the reducing agent that we use is what? Coke, which is one of the allotropic form of carbon. So carbon is acting as reducing process. That's why it is also referred as carbon reduction process, and it is also referred as what? Smelting. So the smelting or pyrometallurgy of zinc oxide to zinc is carried out in a special type of furnace which we refer as what? Vertical retort furnace. Now you just look at the diagram of the vertical retort process. You can see the internal structure of this vertical retort process. Student, if you will just check that this wall of the vertical retort process or this furnace is made up of fire clay bricks. So the question is that what are fire clay bricks? Like in the river battery furnace and this furnace also, this wall which is made up of the brick should withstand with very higher temperature, since we are going to heat the internal content at very high temperature. So this temperature resistance brick is made up of silicon carbide, which is a refractory material or which can withstand at very high temperature, which we referred as fire clay bricks. Now into this furnace we are taking a mixture of zinc oxide and the coke. But if you'll see, for the feasible reduction, zinc oxide is taken 40% and coke is taken what? 60%. This zinc oxide and coke mixture is taken into the form of briquettes, and this briquettes or small pieces is fed from to the top of the furnace. So if you will fill this powdered form of the zinc oxide and the carbon, so about 3/4 part of this furnace is filled with what? This mixture. Now we have to reduce this mixture, but this reduction takes place at very high temperature, and that's why we refer it as what? Pyrometallurgy. Since pyrometallurgy involves heating of the content, so how we heat this content? If you'll see, there is heating jacket which is associated with this fire clay bricks. So this heating jacket is filled with producer gas. This producer gas is mixture of carbon monoxide, nitrogen and air. So carbon monoxide and nitrogen and air is filled onto this heating jacket and it is allowed to burn. Since the process is highly exothermic, so it just heat up this fire clay bricks, and from here the heat is transferred inside, and which heats the content, that is this mixture. So at about this 1673 Kelvin, the reduction starts. This at this high temperature, if you'll see, this carbon which is acting as what? Reducing agent, it starts removing oxygen from the zinc oxide. As we know that as per thermodynamic principle and Ellingham diagram, the formation of carbon monoxide takes place at very high temperature. So this carbon which is obtained from the coke act as reducing agent, and this reducing agent removes oxygen of the zinc and it forms two gaseous products. Carbon monoxide, the gaseous product, and the zinc metal is also gaseous product. Why we are saying zinc metal is also gaseous product? Because if you will see, the zinc metal which is obtained in the form of zinc vapor and the carbon monoxide, the temperature at which this furnace is operated, if you will compare this temperature with the melting point and the boiling point of the zinc, then you will find the temperature of this operation is higher as compared to the melting point and the boiling point of the zinc. So in this case, the zinc is obtained into the vapor form along with the gaseous product carbon monoxide. So onto the upper part of this vapor, this furnace, if this vapor is collected, so this vapor is allowed to pass through this. Now this next joining part with this vertical retort we referred as what? Condenser. So the role of condenser, all the gaseous product which has come here to condense it, but the temperature which is maintained into the condenser only condenses zinc vapor, because zinc being high boiling point of the melting point,
it is easy to condense as compared to carbon monoxide. So here the zinc is obtained into the liquid form, and this liquid form of the zinc which is obtained is a crude zinc because it is consisting of various impurities, and this crude zinc is referred as spelter, or you can say it is what zinc spelter. This zinc spelter mainly consisting of cadmium, lead and iron along with zinc. The maximum percentage of the impurities which is referred as what cadmium. So we say cadmium is the byproduct which is obtained into the extraction of zinc. After getting this zinc spelter which is just taken out from one side, student, it is a continuous process. From one side we just adding this mixture, and from other side if you'll see by roll discharge mechanism all the waste product can be taken out and all the gaseous product can escape from the condenser. So this is how we carry out the reduction of zinc oxide to zinc metal. Please remember this process is referred as carbon reduction process, as this coke is acting as what reducing agent. In previous step we got zinc spelter. Student, zinc spelter represent crude metal which is consisting of what impurities. So in order to remove impurities we have to purify the metal. So this is done under the step of what, refining. As we all know that refining is consisting of various methods, but the best method which is selected for zinc being a more reactive metal is what, electrolytic refining. So we are carrying out electrolytic refining of zinc spelter. So before that, zinc spelter is first dissolved into dilute sulfuric acid. So on reacting zinc spelter with the dilute sulfuric acid, only the zinc metal react and it forms zinc sulfate. If it contains 3% of H2SO4, so zinc sulfate along with the 3% of H2SO4, it can act as what, electrolytic solution. This electrolysis is carried out by using aluminium cathode and lead anode, and we are supplying the voltage of around 3.5 volt. So during electrolysis what happens, the zinc sulfate breaks into Zn2 plus and SO4 2 minus. So this Zn2 plus ions, it starts depositing onto the surface of cathode and all impurities remain inside the solution only. So we can say the pure zinc is deposited at aluminium cathode. So this is how we obtain what, zinc metal. So extraction of zinc metal, if we just want to revise in the form of summary, then we can say that first the ore that we are taking is what, zinc blende, that is zinc sulfide, which we referred as what, chief ore of the zinc. So this zinc sulfide is first concentrated by using gravity separation, electromagnetic separation, and the main process is what, Froth flotation. After concentration, this concentrated zinc blende is subjected for extraction, and for the extraction we are doing the process of what, roasting. So what we do in the roasting, this concentrated zinc sulfide ore is heated in excess of air so that it gets converted to what, zinc oxide. Now the next step of the extraction involve what, reduction. So it involves carbon reduction process, and that is done in the vertical retort process, and we get zinc spelter which is referred as crude zinc, and this crude zinc is refined by electrolytic refining till we are getting what, pure zinc. So this is how we get pure zinc from zinc blende, and these are the various processes involved during metallurgy of zinc. So on the basis of above discussions, we all have to solve this worksheet which I am giving you. So it's worksheet 3.1, which is consisting of match the following type of the questions and also true and false. So all of you try to solve it. You just take 2 to 3 minutes and you try to solve it, and after that I will tell you the exact answer. Pause your video and solve it. I'll get back to you after 3 to 4 minutes. Well, so let's check the answers. In the very first question, they have asked about match the following. So first column, they have given the property or the working of the refining method, and the second, they have given the name of the refining method. So we have to check which processes are used for a specific type of refining method. The very first, if you will see, so it is a refining method which involves principle of electrolysis. So out of this, zone refining, electro refining, vapor phase refining, and chromatography, the refining method which involves principles of electrolysis is what? Electro refining. It involves heating of one end of the metal. Such type the processes are carried out in the zone refining. Involve principle of adsorption. So chromatographic refining method based upon principle of adsorption. Involve formation of volatile complex followed by its decomposition. So it's vapor phase refining, which is consisting of Mond's process in nickel and Van Erkel in case of titanium and zirconium. Now let's check the answer of true and false. The very first statement, they are saying electrometallurgy is a process of refining method. So the statement is false, because electrometallurgy is the process of what? Extraction. It's not refining method. Electro refining is the method of purification of the metal. Liquation method involve heating of metal in inert atmosphere of noble gas. No, it is also false, because liquation method involve only making metal. We are heating metal onto the sloping earth and we are melting the metal. So third one, if you'll see, in electro refining, pure metal is kept at cathode. Yes, it's true statement. Fourth, low melting metals like bismuth, tin, lead and mercury are refined by liquation. This is true statement. Mond process is used for refining of nickel metal. Yes, it is correct. Zinc oxide reduction take place in reverberatory furnace. No, this statement is not false, because it has to be vertical retort furnace instead of using this. The next worksheet, and this is consisting of worksheet 3.2 and fill in the blank. So all of you try to write appropriate and correct word for the given statement. Now you all can pause the video and you try to solve this. You just write the answer. Please don't copy entire statement. Come on, your time starts now. Yes, student. So request that all of you please pause the video and solve it. Well, so let's check the answer. Answer for the first one, we all have to write the correct appropriate word to this given statement. Purification of crude metal is called. In electrometallurgy, this process is referred as refining. Second one, smelting of zinc oxide is also called as, see, this process is referred as carbon reduction process, because smelting of zinc oxide involves reduction of zinc oxide, and for that purpose zinc oxide is heated with carbon. So that's why this is referred as carbon reduction process. Third, if you'll see, impurities obtained at anode during electro refining is called as, this is referred as anode mud. Zinc splinter is a dash form of zinc. Zinc splinter is referred as impure form of zinc and it contains cadmium, lead and iron as an impurities. Electrolyte used during electro refining of metal should contain same metal ion to which is refined. Chromatography column is filled with as an adsorbent. There are two substances used. It can be silica or alumina. Chief ore of zinc is its sulfide ore and this ore is referred as zinc sulfide. Zone refining is used to purify semiconductors like silicon, germanium and also gallium. Second last, that hierarchical method of vapor phase refining is used to refine titanium and zirconium metal by forming its respective iodide as volatile compound. 10th, if you see, electrolyte used in refining of zinc splinter is the mixture of ZnSO4 zinc sulfate plus 3% of dilute H2SO4. So these are the correct answer. I hope you have got it. Now this worksheet that you have to solve as a homework. So you all have to write the correct answers of all the questions which they have asked. Got this?